Hi, and welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And my guest today is Richard Herrington. He is the head of the Earth Sciences Department at the Natural History Museum in London. Dr. Herrington, welcome to the Power Hungry Podcast.
Yeah, thank you very much, Robert. Thanks for inviting me to take part.
So I did warn you that I have my guests introduce themselves. You have a long CV and a PhD and a whole lot of other things. You've had a career in geology and mining. If you don't mind, please introduce yourself.
No, I'll give you a very brief resume. So I trained as a geologist, a mining geologist, way back in the 1980s. I then went to work in the mining industry for a period of time before. So that was working for a Canadian exploration company who were actually seeking new metal resources, and I spent a lot of time in that business. I then went back to university to study the science in more detail. I became much more interested in the science behind how deposits were formed and where they were located. So I went back to university and I completed a PhD, and I've come to the Natural History Museum where I picked up a career in research that was focused on indeed looking at new sources of metals where they might occur in the crust. But then also more latterly, I've been working on things that of making exploration more effective, reducing the footprint of finding those new metals, also improving the recovery of metals. So looking for technologies that would improve recovery, but also how I can use my science of mineralogy. So my sort of key skill is mineralogy, understanding minerals and the metals that are within them. And how can I use that skill set to get better recovery from the existing materials? And then more latterly, we've been starting to work on how do we make mining more effective, its legacy more effective, basically trying to avoid the kind of waste that we might have seen in some legacy mines historically that have got obviously an incredibly bad press. But obviously a new industry has to do things in a way that leaves a sustainable legacy. And so that's part of what I'm doing now. And so that's kind of all linked into now the demand for metals and minerals has skyrocketed as a result of us revolutionizing our energy business. So we're effectively moving from a carbon-based energy economy to effectively a minerals-based energy economy with renewable technologies, all of which need materials, metals, and minor elements to make them work. And so
I like the way you put that, from carbon to minerals and metals, and that was where I first came across your. Sorry to interrupt, but that was where I first came across your name. Was this June 3rd, 2019 letter that you co-authored with seven of your colleagues to the Committee on Climate Change, and I then wrote about it in the New York Post, and I've written about it several times since then. Yep. But if you don't mind, since the listeners to the podcast aren't familiar with this letter, can you give a quick summary of what you wrote in that letter?
Yeah, I basically pointed out, just did a very simple calculation for the United Kingdom, taking the statistic that we have 31.5 million internal combustion engine vehicles, privately owned vehicles in the United Kingdom. So I just did the calculation of converting all of those cars, swapping one for an electric vehicle, and with the current technologies as we know them, work out what was the material need for replacing our vehicles. And not to put too fine a point on it, it basically took a couple of years of world production of lithium. I think it's several times the production of the annual production of cobalt, a significant increase in the amount of copper, up to sort of 10 or 12% increase in the amount of copper that we'd mine in a year, just really to replace the motor vehicles that are in the United Kingdom one for one. And scaling that up worldwide, if we took all the cars that we know that privately owned, you'd multiply that by 40 times to get the rest of the world to convert all their internal combustion engine vehicles to battery electric vehicles. So it was really opening people's eyes to the fact that we need those metals to make those cars, because every electric vehicle has a lot more copper because it's got copper wiring. The batteries are using lithium and cobalt, and so a lot of the metals are common. So
the other
all of those kind of things are made from the same metals. But
the other ingredient, of course, in the EVs, right, is the rare earth elements, the neodymium, praseodymium, lanthanum, all of the ones, yttrium.
Yes, that's correct. You need a year, about 3/4 of the year's production for that, and that's in the drivetrain. So the electric motors that are in the average electric vehicle needs those special rare earth elements in the drivetrain. So you're absolutely correct. There's a whole range of different things that are there as a result of you taking the power plant, the hydrocarbon power plant out and putting an electric power plant.
Right.
But then, the other thing then, did a calculation, of course. There are all those electric vehicles, they have to recharge themselves. So, you drive them and overnight you have to charge them or whatever. And just did the calculation on that. The UK would need to up its generation of electricity by about 20%, so that you need to actually, even the current electrical supply, which is coming from a range of technologies, obviously, we would need to increase the terawatt hours of power generation by about 20% for the UK. And again, you would factor that in. That would be the same for every other country,
Sure.
US.
Well, and it seemed that last part seems particularly relevant now, given that Britain's in a full-on energy crisis. I mean, it is just these are all things that seem to be coming to the head at the same moment. No,
it is rather unfortunate that we've at the moment the gas deliveries to the gas stations is a fault of not enough drivers, apparently, and actually out there it's all dying down a little bit because people got a bit excited that fuel might be on short supply, and they kind of went out and filled their cars up.
Right.
There's the gas situation, because obviously a lot of our power generation, we closed our coal-fired power stations. We've got a lot of gas-fired power stations, but we are seeing a squeeze on gas supplies at the moment. And you're absolutely right. That is, we've got rocketing prices. It's putting a squeeze on the UK, and actually, the acceleration to other forms of power generation would seem attractive at the moment. If we could get more renewables into the frame, that would be great. But we haven't got that built infrastructure just yet, so we are still reliant on gas at the moment.
Sure. So I just want to repeat what you said here, because it's from your June 2019 letter to the Committee on Climate Change. And just to restate what you said about the number, if you wanted to replace all the vehicles in the UK with EVs, you listed the number of tons of neodymium, dysprosium, 2.3 million tons of copper. This represents just under 2 times the total annual world cobalt production, nearly the entire world production of neodymium, 3/4 of the world's lithium, and at least half the world's copper production during 2018. Even ensuring the annual supply of electric vehicles only from 2035 as pledged will require the UK to annually import the equivalent of the entire annual cobalt needs of European industry. I mean, these are just daunting numbers. I mean, by any way that you slice it, and then we're talking about just for the UK. And I've done some. Go ahead.
No, you're correct. I mean, I will correct that because the letter unfortunately had an error on the copper. It's not. It's about 10 or 12% of the copper production. It's not 2 times. So that was the 2 times was if we scaled it up to the whole planet.
Whole world. Oh, I see.
Yeah, unfortunately that typo got into there. But those other figures that you just quoted to me are correct. So yeah, it's 2 times. It's 2 times the cobalt. I think I said twice lithium, but I meant cobalt.
Right.
And it's about 3/4 for lithium. But it's substantial. Even in relative terms, it's high. But in real terms, an extra 2.5 million tons of copper is not a small amount. And then you build on top of that the metal that you need for the power infrastructure for recharging and renewables. It increases on top of that.
Well, so let me ask the obvious question here, because and I'll just I did some calculations based on yours, and maybe the copper numbers may be off, but I figured that then extrapolating your numbers to the U.S., that electrifying, and I've published this a number of times, just half of the U.S. auto fleet converting to EVs will require, in rough terms, 9 times current annual cobalt production, 3 times global lithium, and 2x global copper. Now, so the copper numbers may be a little high, but I guess the reason I wanted to have you on was just on the podcast to talk about these things, because is this. It seems almost the numbers that you're talking in both absolute terms and in percentage terms just seem, leave me slack-jawed. I mean, is this even possible that global mining output, this is your field, can respond in a way that is significant when we see since 2019, I looked it up, the price of copper has more than doubled. China has made it clear they're going to take care of their own rare earth element needs first before they export. Is this even doable? I guess is the thing that keeps coming back to my head when I look at all this talk about energy transition and the rest of it, especially now as Europe is using more coal, the Chinese and Indians are burning more coal. There seems to be, in fact, a retrenchment and going the other direction. So I'll restate the question. Is this even possible to scale up global mining to the point where to achieve the numbers that you've laid out back in 2019 and again in the piece that you published in Nature Reviews Materials in May?
Yeah, well, it is a serious challenge. I mean, what I would argue is that we can do that, but what it does need is us to develop on stream choice of supply, because one of the big issues we've got at the moment is that current production, for example, for cobalt is coming from Central Africa mainly, and in case of lithium, we've got supply from South America and Australia. Now, with regards to, let's just take lithium, scaling up lithium production in Australia is possible, but not to provide everything that we need. Likewise, in South America, there are issues of scaling up there because there are some environmental issues relating to water. So if we scale up there, that's going to create serious issues that it may well be that the regulators won't permit that scaling up. So what indeed we need to do is to make sure that we bring other resources, and we know geologically those resources exist, but it does need concerted effort to make sure they're brought into the mix of supply. And in the case of lithium, that is actually happening, because we're seeing, for example, in the United Kingdom, people are exploring for lithium in Cornwall. There's a big deposit in Serbia that Rio Tinto have been sitting on for a number of years, which is now actually going ahead because they realize that this is the right time to get this into production. So we know that there are some alternates. What's happened in Africa is that's also a place that could scale up cobalt production. And people in the past have been worried about child labor issues in the supply chains. And what we've seen actually is that there's been an improvement in being able to secure those supply chains and make sure that we don't get cobalt that's coming from child labor into the supply chains. So to some degree, we are seeing an ability to scale up. And but the problem that we've had is with the addition of the COVID crisis, it has slowed down production of a lot of these things, and then the transshipping. So we have had probably a couple of years of quiescence in that sort of growth. So I share your concerns with being able to deliver that on time. I see no reason why we can't scale those, but it needs to have concerted effort, and B, we really need to be getting at it now. So concerted.
So I'm sorry to interrupt, but concerted effort. But it's also, we're talking about tens of billions, hundreds of billions of dollars of investment. I mean, on if we're talking about doubling, tripling lithium, doubling, tripling cobalt, maybe doubling or tripling copper. I mean, these require massive investments. I mean, but is that fair?
Well, yeah, it is, but there is money out there to do that. I mean, I think a lot of what we're seeing is that the sort of hydrocarbon-based economies of the world will be moving into that, and the investment effectively into those sort of renewable resources for, renewable energy is being stimulated by those economies, realizing that that's the way it's going to go. And I think it's there. There are quite a few startup companies that have approached me that are working in trying to put those resources there. So I think what we're going to be moving towards is probably a series of smaller, more sort of disaggregated producers who effectively manufacturers are going to have to get more closely involved in that supply chain and maybe develop offtake agreements directly with producers. So I think that's going to be an attractive way forward. And I don't know if that's the case, but we may be seeing some stimulus from manufacturing putting direct investment into where their raw materials are coming from. Because in the sort of in the open market days, people just sort of traded these on the world metal markets. But to secure the supply for your own factory, it may mean working directly with producers. And I know a number of organizations, some of the car manufacturers are doing just that, so that they can effectively track their supply chain from the mine gate to the battery factory, and then secure their production.
Well, I'm glad you mentioned that, because that was what I was going to mention next. And I wanted to talk about cobalt, because I know that after some of the exposés were done, CNN did a very good one on the cobalt trade in the Democratic Republic of Congo. And since then, as I recall, Daimler and a number of other auto manufacturers have then gone further up the supply chain to become more vertically integrated, right? To make sure that they're, can certify that it's not child labor. But you mentioned, when I think we exchanged emails some time ago, and you said that you identified cobalt as the of all of these critical minerals, that seemed to be at that moment the most problematic. Is that still your position?
Well, it potentially is, because there is a big resource out there that is now being investigated by some people, and that is the deep ocean floor. You're probably aware of these manganese nodules that occur in the deep Pacific Ocean, and there is an enormous resource of particularly for cobalt. There's copper, there's nickel, there's manganese, the battery metals, if you like. There's huge resources of those on the deep ocean floor. But they look like little potatoes that are grown. They grow on the ocean floor, but they are hot potatoes, and it's a hot potato topic because a lot of people think that the deep ocean should be left alone, and in fact that's there's effectively at the moment there is a de facto moratorium on mining because nobody has been given the go-ahead to go and mine on the seafloor. But quite a lot of companies are investigating, and but we don't really understand enough about that environment from the biodiversity point of view. So there are a lot of companies who are saying we don't want to get our cobalt from the deep ocean floor, but until we have all the data, we're not in a position to say, is it better to get our cobalt from the deep ocean floor, or should we get it from a mine in a rainforest? Unfortunately, it's come down to a choice, because if we want to get to net zero, we need those metals. And if we then have to say where we're going to get them from, because as you say, there's a scale here, we're going to have to mine more. And it then comes down to a choice. And so it is a question of, do we take it from a terrestrial mine setting, or do we take it from, let's say that the choice for, say, cobalt would be deep ocean floor deposits.
But it's kind of a different. But it
should never be mining on the deep ocean floor.
Right, but it
might be that if we looked at the data rationally, society needs to make that decision as to whether we leave the deep ocean alone, or we put it in the mix of choice.
Right. But I mean, you say put it in the mix of choice. I mean, these aren't easy ones, right? Because in the Congo, you have this history of conscripted labor, call it slave labor, child labor, it's by all accounts, it's a fairly unsavory mining industry there. or going to the deep ocean. And one of the guests on my podcast recently was Jesse Osabel, who's a great advocate for oceans and leaving oceans alone. And so there is going to be, I guess this is the question that I thought, it occurred to me as I was preparing for our interview, was mining is a difficult business, and it only seems like it's getting more difficult all over the world because the scrutiny of the mining industry is so much greater now. Yeah. So, I mean, I'm not asking you, is this hopeless, but I mean, is there a natural limit on what the ability of the earth in terms of overall productivity, what those limits could be given these societal constraints as well as the physical constraints?
Well, and I would say that society have got to make that choice. So it's a question of, we should be showing people, you want these technologies. If you have these technologies, you need these resources.
There's a price to pay. There's no free lunch.
There's a price to pay. Now, the price might be too great. And there's no doubt that in some situations, the price might be too great. And we'll say it's not worth paying that price. We'll just do without that product. But, if the product is the very thing that will solve, the climate issue by weaning us off burning carbon, it's a tough one to say, well, we're not going to bring that technology in that's going to solve it. Now, there's a lot of talk. There are other technologies out there other than lithium cobalt batteries, but they're not tested. They're not tried and tested. And we all know what happens when you bring in a technology that's not tried and tested. Probably remember the issues with Samsung mobile phones when they brought in a brand new battery and the phones were burning up.
Right.
Similar problem with the new Boeing planes. Their lithium batteries were overheating. So this was a technology that probably wasn't completely tested adequately. And I think industry is very reticent to put in a new technology that's unproven. We now know that lithium ion batteries, with lithium, cobalt, nickel and so on, they work really well, they're proven, and it's a technology that works, and we know will reduce our consumption of carbon and use of carbon. So we really, if we want to be strong about this, we're going to have to bring that technology in. So the choice is, we either use fewer cars. Maybe you tell the US and Britain, you can only have half of those cars that you used to have. So maybe that's the decision that needs to be made. Or otherwise, you're going to have to say, well, you're going to have to get your metals from mines. But, there's one thing that I raised in that paper of mine in Nature Reviews Materials is, what we could start to look closer to home for some of these metals. And, we're doing that in Britain. We're looking for lithium down in Cornwall, which is an old mining district. Lithium was never mined before, so the lithium was left in the grounds. We could go back and get, at least 30% of what UK needs for its batteries could come from mines in our own country. But that's a question then we have to pose back to people saying, well, we can bring mining a bit closer to home, a bit like we talk with agriculture. Maybe if we do agriculture closer to home, we're more careful about how it's done. Maybe it's the same for mining. We could actually make mining better and we could keep an eye on it better if it was done in regulated jurisdictions. That means bringing it home, and nobody really likes a mine in their backyard. But if it's paying the bills, it's solving the planetary issue, and you've got no problem of the security of supply. Perhaps that is a cost worth burdening yourself with.
Right, and it may be more appetizing or an easier sale than importing it from somewhere else, from Chile or from Bolivia or et cetera.
I'd be much, personally speaking, I would be much more in favor of permitting a mine that was going to mine cobalt or lithium than I would be a new coal mine. And there's been issues in the UK about permitting new hydrocarbon, carbon. Coal, basically. Right. But, if it was bringing a technology that was going to solve the CO2 problem, as a personal perspective, I would say that's a price worth paying. Now, we have that's choosing metals over carbon, right? Or as you discussed earlier. Exactly. Or the other choice is, let's not have any electric vehicles, and then that's an easy choice because then we don't need the metals at all.
Right.
But society's the only has to make that choice.
Sure. So, as a reminder, my guest is Richard Herrington. He's the head of the Earth Sciences Department at the Natural History Museum in London. You can find out more about him at nhm.ac.uk or look up his paper that was in Nature Reviews Materials published in May. Let me quote you from that paper that came out in May. You wrote that mining remains necessary to deliver validated technical solutions needed for the rapid decarbonization demanded in the pledge about net zero, you were writing. And you said new mined resources will be required in the short term to enable green technologies and infrastructure. There are sufficient geological resources to deliver the required metals. That's the part that I thought was interesting. And I've talked with my father-in-law. He's a PhD chemist and taught at University of Michigan for many years. He's retired now, but he's told me many times, yeah, they call them rare earths, but they're not that rare. So that true? Is that true? Because, I mean, it's an interesting, and I wrote about it in my book, Power Hungry, 11 years ago, about the lanthanides, and that these are the green, they call them the green minerals, right? Or the
green metals,
the green metals. But so neodymium, praseodymium, all those ones in that row of the periodic table of the lanthanides, they're not that rare, but China controls has a stranglehold on their supply, no?
Well, they do, because they're the resources that we're prepared to mine at the moment. But worldwide, we have geologists have discovered new resources for all of those metals. So we do have a choice. We can go to other places for them. But currently, we've been happy to accept China having a stranglehold on those resources because everybody's played balls to date, and we've been able to get the metals that we need. As times get squeezed, like we've seen with the power crisis, and places like Russia perhaps slowing down the gas supply to Europe because they have an agenda, you do have the concern when you've only got one country supplying materials that I'm not saying they will, but they could have that ability to say, you know what, we'll just squeeze the supply a little bit. Whereas if you had a choice, and we do, if we put more effort into looking at alternate supplies, there are some really interesting new resources of rare earths in places like Madagascar, which is a problem in itself because it's a biodiversity hotspot. It's not the place perhaps you'd want all your mining to be done. But also in Australia and Canada, no? Haven't I read some
reports about rare earths there? But you also have the problem. There was the Molycorp mine here in the U.S. in California. They scaled up and they were looking at rare earths. This was 5 or 6 years ago. They scaled up, and then I don't know what exactly happened, but whether the Chinese flooded the market and then they went out of business. I mean, they were only in business for a couple of years, and then they couldn't make it in the market. And so, it just seems like a really fraught, given the constrained trade in these metals, and that China, when it comes to, I also in manganese, zinc, copper, rare earths, they in almost all of those, even in copper, they control either, in terms of refined product output, half or more, I think, with the exception of copper. I mean, the IEA report in May really laid this out in a way clearer than I'd ever seen before, but really underscoring China's role or China's control, rather, over the supply of nearly all of these critical minerals. Can you talk about that for a minute?
Yeah, absolutely. I mean, it's a fair observation. If we look at the criticality index really for metals.
At criticality index, I've not heard that term before. Is that a new one?
Europe and indeed the US have this. So that in 2011, the EU put out this index of the critical raw materials, and there were 14, and it's been expanded now. And the basis for those is their essential nature for the new economy, and then the other one would be the security of its supply, and that would be down to monopolistic effects, like only coming from one country, or where both where the refining was controlled, or there could even be a company monopoly. So for some commodities, one company might be controlling significant amounts of material. The case of some platinum group metals, for example, there's a mine the Norilsk mine in Russia is the key producer of things like palladium, and that's a really important metal used in catalysts in a lot of things, fuel cells included. So
right.
they're used in automobiles, obviously, as catalysts for
Catalytic
exhaust.
converter. Yeah.
But they're also used in fuel cells, which are at the front end of a hydrogen-powered car, for example.
Sure.
So these are important metals that are controlled. So absolutely, and I think that criticality index is like, how important is it? Cobalt's really important because we need it in the current batteries, but it's also coming from only one country. So cobalt's in the top right-hand corner of criticality. Other metals might be really, really important, like lithium, but currently the supply chain isn't too bad. So although they're up there, they're not at the top right-hand corner.
And where would people? I'm just curious. I'm sorry to interrupt, but where would people find the criticality index? This is new to me. I'm not. Don't claim to be an expert, but I'm passingly familiar with these issues. Where would I look that up?
Right. So the European Union published some reports on critical raw materials, and you can have a look on their website. I can't give you the URL, but if you kind of Googled EU critical raw materials, you'd be driven to that report that would put all of that into some
and so cobalt, as you say, would be in this upper right hand corner, whereas iron would be in lower left hand, or maybe not even on the list.
No, iron's not on the list because we have got a lot of it and it's coming from such diverse supplies that actually it's not critical. Although of course shipping is becoming, we've seen that with the Suez Canal getting blocked. We had some supply issues with shipping stuff around the planet.
Sure.
That isn't included in that. But if you were to put in the fact that if there was a squeeze on shipping, like we've just had a squeeze on petrol supplies because we don't have enough tanker drivers to drive the material to the. So we've got the refineries producing petrol, but it's not getting to the fuel pumps. Then that's another issue, which currently isn't put into people's supply chains, but probably.
Well, as you say that, one of the things that comes to mind, Richard, is just the I won't want to use, the right word isn't tenuous, but how interrelated and close, how closely all of these issues are aligned, right? And that have we gone to sleep on the supply chain issue? I guess would be the question that comes to mind, because we've depended on more just-in-time delivery. We've depended on, it's okay to import it. But now we're looking around the world and saying whether it's antibiotics or copper or any of these other things, well, wait a minute, we're dependent on China for all this stuff. Why didn't we know this? And it's really kind of what you're talking about is actually the idea of reshoring a lot of different industries that we've kind of gone to sleep on. Is that a fair way to think about this?
Well, I think it probably is. I think the COVID crisis has alerted us to the fact that just in time was a philosophy for not overstocking with things, but then when you get a crisis, I mean, we had a particular issue in Europe, UK, of personal protection for our health staff. I think probably that was felt over the world because, I mean, you don't want to keep boxes and boxes of PPE, but when you've got a crisis, you suddenly need them. And of course, the world needed them, and it created an issue. So yes, I think we might well have taken our eye off the ball for that. And I think this is why, with the metal situation, we do need to make sure we secure that supply chain. And to me, I keep going back to this idea of choice. If we have a choice of places we can get it from, then when there's a squeeze, you can't get it from somewhere else. There's a chance to get it, from a different source. Of course, the problem with that is that, like you talked about Mountain Pass in the US, where they geared up to produce rare earth elements when the markets were really good, then someone floods the market and effectively, in a way, deliberately closes you down, and so that becomes an issue. But I think. Maybe
and was that what was that and sorry to interrupt, but was that what happened with Molycorp in the Mountain Pass?
I don't know, because actually I think there's Chinese equity in Mountain Pass, so I don't think that was an issue particularly, but I do think it reflects the fact that rare earths were not super squeezed. There wasn't a huge under supply. And I don't think, for a lot of metals, we do have quite a bit of slack in the supply chain in the near term. But, as we go up to 2040, if we're delivering net zero, we need to make sure that we keep that ability so that we don't get an issue where we get a squeeze. Now, I think with rare earths, it was just oversupply, frankly.
Huh. Well, as you're saying this, Richard, one thing that comes to mind, and again, my guest is Richard Herrington. He's the head of the Earth Sciences Department at the Natural History Museum in London. His name and work came to my attention in 2019 on the letter that he wrote along with 6 or 7 colleagues to the Committee on Climate Change about critical materials and their role and importance in the net zero transition. You can find out more about him at nhm.ac.uk or look up his new paper in Nature Reviews Materials, which was published in May. But as you're talking about this, Richard, what I hear you say, or what is inferred, is that necessarily to do this kind of reshoring, you're going to need a stronger hand of government in mining. The government is going to have to say, no, these are critical materials we can't allow, or we can't trust Russia or China or Congo, or we have to have a firmer and greater role in this production, delivery, refining, et cetera. Is that, am I hearing you correctly, or is that what is in fact the case?
Well, I think governments need to wake up to the fact that we will, that they are the ones making the commitment to the change, like the net zero. They have to make sure that there are mechanisms to be able to deliver the metals to the manufacturers. So I think it's quite a complex issue, and it would be down to looking at places where maybe there is legislation that are barriers to diversifying the supply. So I would say that we don't want things to be, reducing the oversight, the governance on particular projects. But what we may feel that we should do is let's get the true costs of these things evaluated so that we're kind of on a level playing field, and we factor in things like the impacts, for example, social impacts. But we talked a little bit about the effect on child labor might have on the market.
Right.
Well, if we need to make sure that if there is a sniff of that kind of activity, that we close that down so that there is a true price being paid. Because one of the issues we've got is that we should be increasing the amount of metals that we recycle. And there is a barrier or a risk of a barrier to recycling. If we make new mined commodities too cheap, we won't develop better recycling strategy. So one of the things might be that some of these commodities are too cheap to mine. So we go and mine new stuff, whereas actually we could get quite a lot of this from recycling. So there needs to be, I think that's where governments can help. And then in fact in the EU, there is legislation to make sure that when you build batteries for your cars, that inbuilt in that is the mandate that you have to recycle those batteries at their end of life.
And isn't that one of the key challenges I know in talking to people in the battery business, that lithium batteries they're devilishly hard to recycle. I mean, the lithium is not worth that much, whereas lead acid batteries, something like 98% of them are recycled. It's one of the most recycled consumer products in the world.
Well, it is, because lead is toxic. So therefore there's a zero tolerance of lead being thrown away. Now, in order to force people to recycle lithium, there may have to be a zero tolerance on throwing things away. So, I mean, that's certainly in Europe, it's legislated, the amount of materials that have to be recycled. And I think that's probably the same in a lot of parts of the US too. I know that they have targets for recycling. And it's happened for lead acid batteries, because you're right, the metals are a higher value than lithium, but also because lead is toxic, there's a huge penalty for allowing that to get into the waste cycle.
So it's more than one regulation, more than one issue at hand here that determines the recyclability or the recycled recycling consistency or percentages.
But lithium, you're correct. Lithium is a lot cheaper to get as a new raw material than it is from a recycled battery, and that's one of the issues that we have is that could well be inhibiting recycling is because the quality of the recycled material might not be as good as a newly mined material.
Sure.
So therefore, that's to me that's the biggest place where there could be an intervention on legislation to make sure that we don't put waste batteries, for example, to landfill.
Sure.
That would be a crime.
So let me switch. We've talked a lot about EVs and their role here, but in your letter from June of 2019, you also talk about solar and wind, and you talked about wind turbines and the amounts of neodymium and dysprosium in them. Again, back to the rare earth elements issue. And so it's in the turbines, we're talking about magnets, right? Neodymium iron boron magnets. That's the key technology, both in the turbines and in electric motors, right? For electric vehicles. Tell me what is it about neodymium? What is that? Because it's one of the rare earths that I hear about the most and am most familiar with. Why is that such a critical element?
Well, it has these amazing properties when you incorporate it into a magnet of just the sort of power to weight ratio is enormous, enormously good. I mean, that's the key reason. And they can be crafted. You can produce these sort of ceramic magnets. They're easy to machine and put together. So technologically, they've got a better power to weight ratio. So for a car, of course, that's a big driver. I mean, there are other technologies out there that you can use cobalt magnets that are nearly as effective, and therefore you can cut out the need for rare earths. So there are some tricks to get around the problem, but in broad terms, the best quality magnets for wind turbines and for in some applications encompass this. They have this neodymium and dysprosium component to them.
Oh, okay. So it's neodymium and dysprosium, but they're generally known as neodymium iron boron, right? Isn't that
well, neodymium's the key part of it, but there's a bit of dysprosium in some of them as well. It's a bit of a cocktail. But
I got you.
Yeah.
So speaking of cocktails, let me talk about solar here. That's not a very good transition, but I'll make the transition anyway. You also mentioned polysilicon when you talk about solar. And this has been another supply chain issue that has really come up just in the last few months with the issue of slave labor in Xinjiang in China, with the polysilicon production there. So it seems like we're talking about mining, but they're inextricably linked to these social issues around slave labor. Let's call it what it is. Then the repression of the Uyghur minority in China. I mean, I guess when I look at these issues, I think, man, on nearly every front, when we talk about so-called green technologies, you're facing both hard rock mining questions and social questions about how much slave labor is it okay for us to have in our solar panels. I mean, I'm putting it very bluntly here, but that's ultimately what we're talking about. 45% of the world's polysilicon coming from Xinjiang. I mean, these are real challenges, aren't they? How do we solve that silicon issue or polysilicon refining issue?
Well, if we are to believe that these records, there is a problem in that silicon supply. I mean, it's a manufacturing issue, and that is the solar panel technologies are moving on apace. There's a whole new set based around a structure that's called a perovskite structure, which is a different approach to it. So I think because solar's been with us for such a long time, I believe that we will be moving to other technologies in that area. Well, the polysilicon thing spills over to microchips because we've had issues, haven't we, of supply of microchips. I'm waiting for a delivery of an electric car, which is held up because we don't have enough microchips. And presumably,
so you have an electric car on order?
I do.
What is it? What are you buying? A Tesla? What's the story?
Well, I don't know if I should be product placing, but I'm actually buying a Volkswagen because it's the right choice for what we particularly want as a family. But yes, so there is a bit of a supply issue at the moment because of chips for those vehicles. So that's
So
probably
are
going
you're
to,
you're part of the problem or part of the solution here, I guess. Huh? You're one of
well,
the
I mean,
the people
this is it, isn't
contributing
it?
to the demand here.
Yes, I am indeed. But I'm hoping, and I've done the life cycle analysis on buying an electric car like the one I'm buying, and certainly the credit, there is a carbon credit for doing that, getting rid of the internal combustion engine car which we've just sold, getting this electric vehicle over its life cycle. It will be an improvement, but it does expose. You're quite right that there are some supply chain issues for some of these other products. We've just Rob, we've just got to get better at monitoring those. And I think more consumers know about that, then they can make the choice and say, I'm not prepared to have a solar panel from a company that would be doing things in this way. And that's one of the benefits of the sort of open communications we've got. And we should be calling out companies that are sourcing things from places that and using methodologies that we think are unsavory. The thing that my group are beginning to sort of work, well, we've been working on the museum for quite a while, is making sure that the mining operations also don't have a negative impact on biodiversity, for example. So that's another aspect, really, what we don't want is this new mining boom, which effectively there is for these metals. We don't want that mining boom to lead to another issue for the planet. So if we solve the CO2 problem of the planet, but by doing that, we create huge tracts of biodiversity devastation, then we've not really moved on. We've just traded one problem for another. And the social issues are another too, Robert. I mean, that's what
Sure.
Talking about the Xinjiang issue. If truly they are being done in unsavory ways, we should be turning our backs on those supply lines.
So let me ask you a couple of specific questions then here about these critical minerals that we've been talking about. Which ones are the hardest to refine? Or which ones create the most difficulty in terms of the refining process itself, right? Because getting the ore out of the ground is just part of it, right? So once you get it out of the ground, which ones are the hardest or have the most environmental challenges when in refining? Is that the rare earths or something else?
Yeah, well, actually, rare earths are problematic because there are a whole bunch of them, as you know. The lanthanides is quite a long series of metals.
Between what do they call the light ones and the heavy ones, right?
The heavies.
Right.
And there's only slight differences between them. So, trying to get those recovered individually is quite tricky because their chemical properties are quite similar. They've just got a slight difference in their atomic weight. So you use a combination of methodologies that rely on very subtle differences in geochemistry to extract those. So those offer particular problems, and so they're quite energy intensive. So if you can reuse rare earths once you've separated them, that's absolutely terrific. And because going back to zero is tricky. But by the same token, it's if you've got mixed waste rare earth magnets and they're different compositions, it's often as difficult to get those back as it is to go back to the raw materials. I mean,
so it's not just about the refining, as you say, the separation. It's also about but it's also the energy intensity of that process, which you also mentioned in your letter and also in your paper in Nature Reviews Materials.
Yep.
Well, so like a lot of people, I have a cell phone. Which consumer goods are you talked about in your letter about the resource? What did you call them? EVs are resource hungry. What was that? Yes. Electric vehicles are resource hungry.
Yep.
What consumer product is the most critical mineral intensive? What is it? Our cell phones? Is it the electric vehicle? Is there one that you can say this is the most? I've heard about the Toyota Prius being one of the most rare earth element intensive consumer products. Is can you define that, or is that fair?
Well, I think we're entering the realm where electric vehicles are going to be a big issue because there's the volume of them, basically, Robert. It's
the sheer weight of them.
The sheer weight. I mean, mobile phones. a million mobile phones has got, I forget what it is in the way, it's about 35 kilograms of copper in a million. So sorry, 35 tons of copper. So it's not huge. When you think for a car, it's a huge amount. So the mobile phones we're using a lot of, but there's only tiny amounts of those metals in each of those phones. But in a electric vehicle, it's the volume of those metals which is quite high. Right. So I would say that they're challenging. Then also the generation of electricity for that's the next one. So there's a metal hungry transition from going from burning carbon fossil fuels to using effectively minerals.
So solar and wind and the steel intensity, copper, rare earths. I mean, you mentioned that on wind turbines.
We haven't talked about nuclear energy. That that's something in the mix that is also is mineral. Well, it's quite mineral hungry, but it's not quite as mineral hungry as some of the other technologies. So it's more of a traditional use of metals. Obviously, we're going to use uranium in that, but it's like it's got a set of and a lot of stainless steel, but it's such an intensive thing. It's more like replacing a coal-fired power station. You can just plug in a nuclear power station into the infrastructure that went away from a coal-fired power station. Whereas with a wind farm, obviously you've got to interconnect every turbine blade. The solar is the same.
And so you need pylons, you need transmission lines that are. So is that fair? Because it's a line that I've used many times, but it's that the lower the power density, the higher the resource intensity. You're going to have to counteract that lower power density in wind and solar with steel, copper, concrete, all these other things. Whereas you mentioned nuclear, which is all the studies I've seen, everything I've written, has the lowest resource intensity because of the incredible power density of fission. Is that fair?
That is fair to say. Absolutely. And so, we need to accept the issue if we're going to take nuclear, because you're right, nuclear offers a great opportunity. And look, we're waiting for fusion, because if nuclear fusion gets off the ground, that would be a kind of a plug-in to the old grid system, which would be wonderful. But that seems to be at least 10 years off at least. But
and it was 10 years off. And it was 10 years off when I was a child too. So
well, I know that's the problem, isn't it? It's a can that keeps going down the track. But I think the nuclear fission is still a viable technology if society is willing to live with the waste issue.
Sure.
And in some jurisdictions in Britain, for example, it's part of our answer, because we're looking for some of the power problems that, in the cold winter when the turbines aren't turning because there's no wind, the sun isn't shining. We're going to need something to give us a sort of a base load of power, which we used to turn to, obviously, to coal.
And that might be Sizewell C, if you can ever make up your mind on it, I guess, is the...
Yes.
Well, so let me just back up, and then we've been talking for about an hour, and my guest again is Richard Herrington. He's the head of the Earth Science Department at Natural History Museum in London. You can find him at nhm.ac.uk. Let me ask you a question that's not related to necessarily the issues we've been talking about. So what's the mood in Britain now? I mean, I've read a lot of stories. You've seen, a lot of industrial facilities shut down, fertilizer plants shut down. You've had the petrol shortages. You're looking at potentially a catastrophic winter if everything that I read is correct about the natural gas shortages. What's the mood there?
Well, I guess we're kind of getting a grips of a COVID crisis, to be honest, that we're coming out of. So there's still I think there's optimism, because that seems to be, we're finding a way out of that. And there's, I think on that one side, there is some pessimism over the energy, but you know what? To me, it's an opportunity. So another thing, I've got a gas boiler at home that is failing at the moment, and so I'm investigating putting an air source heat pump in that would replace it. So, you know what? It could be a stimulus for change. There are people worried about it, because the energy price for the average person is likely to go up this winter. But
it's going to be what, double? It's going to be what, double, triple, quadruple, something like that? I mean, some of these numbers are just staggering.
Yeah, I guess, but for the domestic supply, we have a cap. There's a government cap on the energy cost to the. So what the effect is that we're having energy companies going out of business, energy supply companies going out of business because they can't increase the cost of delivering to people. So there could be an issue with that, and I think that's where the government are considering how they're going to ride that, because if energy prices do really skyrocket, I'm pretty sure there will have to be an intervention.
The government will have to step in.
Yeah.
Even further, because I mean, you've had what some 20 or 30 different electricity supply companies have already failed or bowed out of the market. I mean, it's very similar, in fact, what's happened in Britain to what happened here in Texas in February. But that's a different discussion.
Yeah,
so
I mean, because
go ahead.
Part of that is because we've got this process that protects the consumer, and of course, then companies can't supply that energy at the contract price, so they have to fold. Because they're committed to a contract price which they can't afford.
Sure. So just two more questions, if you don't mind. So these are questions that I ask all of my guests. So, I mean, you're obviously involved in a lot of issues around geology, mining, mineralogy. What are you reading? What's on your nightstand at home when you it doesn't have to be on your nightstand, on your desk. What books are at hand for you?
Well, I'm actually reading the Cormoran Strike novels by Robert Galbraith. I quite like sort of crime stories. So,
and give me the title again. What is the series? I'm sorry.
It's Cormoran Strike. So, it's the author's Robert Galbraith, but actually it's J.K. Rowling who wrote the Harry Potter series.
Oh, really? Oh, that's her nom de plume.
Writing under a pseudonym.
Right.
So I find those particularly compelling at the moment. So that kind of gets me out of that issue. I've also been reading. Well, I just again read another book on looking at concept of cradle to cradle manufacture. So that's less light-hearted, but it's looking at when you build a product, make sure that you know what it's going to be used for when it comes to the end of its life. I.e. building a proper circular economy. So I'm really interested in reading about that. But so they're the kind of two parallel things I'm reading at the moment.
Right. Crime novels and manufacturing. That's
yes.
It covers the gamut there.
I'm trying to. I'm interested because I think. I've always worked at the sort of sharp end of mining and getting the new raw materials, and there's always been a disconnect between that and the manufacturers. And I think there has to be much more top to bottom integration of. We used to have it where a manufacturer would get the raw material in at the other end, and I think we've got to go back to that to ensure that we have secure supply chains. And I think then we also know where our materials are coming from. We've had that revolution in agriculture so that when a consumer buys something, they fully understand the implications of the product they buy. And I think
so. More back to that vertical integration that Henry Ford had, where he owned the rubber plantations, he owned the smelters, he owned the whole system. Yeah. So last question, if you don't mind. So what gives you hope?
What gives me hope are the colleagues I work with that we are going to solve these issues. I've got a pretty young research group of PhDs and postdocs who are working on technologies but also on trying to solve these supply issues. I'm particularly excited. We've got a new postdoc who's joining to where we are using microbiology to break up rocks and minerals, not using energy. And so the thing that gives me hope is there's ingenuity out there of young people who are up for the challenge that we've got here. It's a challenge we had before, probably at the end of the Stone Age. When we went into the Iron Age, people were going, are we going to have enough iron to replace all the flints? And I think we're at one of those crisis points. But the thing that gives me hope is I'm working with a lot of young people with great ideas that will help solve those problems.
Well, that's a good place to stop then. So Richard Herrington, many thanks for being on the Power Hungry podcast.
Thank you very much, Robert. I've really enjoyed this afternoon.
Thank you. And thanks to all of you in podcast land. Tune in for the next episode of the Power Hungry Podcast. Until then, see ya.